Yesterday, this is where we ended up. This is the last thing that we talked about yesterday. Complementary events. As a review, the probability of an event happening, its complement is going to be the probability of the event not happening. And what's special about complements is over here in this bubble. Complements are events that add up to one complete whole. And we saw that on number 1, where we took the probability of getting an even plus the probability of not getting even, ended up being 6 over 6. Same thing on number 2. The probability of getting a number greater than 4 plus the probability of not greater than 4 equaled 6 over 6 as a sum. On number 3, we wrote down that conclusion. Complementary events add to equal one whole. So if you know the probability that something is going to happen, the probability of an event, plus the probability of not that event, we know that it's always going to equal one whole. The event plus its complement, not event, will always equal 1. That's an important rule to know because we can use it to calculate probabilities. Moving on to number 4, the probability of rolling a 5 or less on a number cube is 5 over 6. So we don't have to calculate that probability. It's given to us, 5/6. Leah and Jasmine calculate the probability of not 5 or less. So looking at their work, they calculated this 2 different ways. They both got it correct, but they did different methods. Looking at Leah's, Leah found the probability of not 5 or less the same way that we did yesterday, or the same way that we would have yesterday. Listed the sample space, 1 through 6. It says not 5 or less, not 5, or 4, or 3, or 2, or 1. Exactly. There's only one outcome that is not 5 or less. So the probability is 1 out of 6. This is what we did in activity 1. But what did Jasmine do? Jasmine found the probability of not 5 or less. So she took one whole and subtracted the probability of getting a 5 or less, which was given to us in the problem, this right here. How would we write one whole so that it has a denominator of 6? 6 over 6. Because we want one whole. So that's going to be 6 over 6. Because there's 6 total outcomes, and one whole would be all of them. So that was Jasmine's method. Basically what she said was, if the probability of getting 5 or less is 5 out of 6, that only leaves 1 out of 6 for the complement. But you can always do what we did yesterday and what Leah did. Just list out your sample space, cross out the ones that are 5 or less, and use what's left over. So far, we've been finding the probability of events from a number cube. But we can do the exact same thing with other experiments, like spinning a spinner. Consider the spinner shown, this one here. All sections of the spinner are the same size. An experiment consists of spinning the spinner one time. Number 1, how many possible outcomes are in this experiment? And then how did you determine this?
6.
So you say 6. Why? How did you determine this?
Because there's 6 sides. Well, like there's 6 parts.
There's 6 sections. There's 6 parts. 1, 2, 3, 4, 5, 6. So there are 6 outcomes because we counted 6 sections on the spinner. All we had to do to get the total possible outcomes for this spinner is just counting how many sections. Why do you think we started out by counting the sections on the spinner? To see how many sections there were. Why might that be an important bit of information for probability? Okay, so that we know what all you can land on, how many sections you can land on. But why is that important when we think about probability? Because that is going to help us get that whole number. That's going to be what part of our probability. We'll come back to that question. We'll come back to it. You'll see it in a minute. Number 2, list the sample space for this experiment. What's a sample space? Can you say it?
The sample space is typically called, like you're basically like parentheses, like parentheses.
Okay, so we got our fancy parentheses. What goes inside those? Go ahead, Omar.
No, it's but there's 2 missing numbers.
Yeah, 2 missing numbers.
Yeah, 1x.
1x3.
2z5.
So that's going to be our sample space. Our spinner has 1x3, 5z, and 2. The order that you write it in the brackets do not matter, as long as you have everything listed. So we're going to do number 3 together, and then we'll do a little activity with number 4 and 5. So number 3, determine the probability that the spinner lands on a letter. On A, describe the event and the possible outcomes for the event. So when it's talking about describing the event and determining the outcomes, we're going to list out the sample space again. And circle the letters. And what are they? X and Z. So on B, where it says calculate P letter, what is the probability of getting a letter?
2 out of 4. 2 out of 6.
2 out of 6. So if we go back to number 1, when I said, why is this question important? Why was that 6 important?
Because it's our denominator.
It's our denominator. Great job. So there were 2 letters out of 6 total sections. That's why we have 2, 6. There's 2 letters out of 6 total sections on the spinner. Okay, on C, it says describe the complement of this event and the possible outcomes. So if this event is the probability of getting a letter, what is the complement? What would we say?
Not getting a letter.
Not getting a letter. So probability of not letter. Good job. So there we've described it. We want not a letter. Now let's do the sample space. So we can circle, we can cross out the letters because we do not want them. And we can circle what's left over. So because it says not letter, that means I do not want a letter. I'm going to cross out the letters. That way I can easily see what's left over so that we don't run into that debate problem from yesterday. So we're left with 1, 3, 2, and 5. Now we have all the information we need to do letter D, calculate the probability of not letter. Four out of six, because there's 4 not letters
And then 6 total sections.
Yeah.
out of 6 total sections. Great.